In this video, we're going to talk about thermal versus photochemical cycloadditions. When we talked about the Diels-Alder reaction, remember that this reaction proceeds with heat, meaning that it is thermally allowed. If you try to do a 2+2 cycloaddition, as shown here, a 2+2 cycloaddition is thermally forbidden. Why is that the case? In the transition state for the Diels-Alder reaction, you have 6 pi electrons that are involved. 6 pi electrons is corresponding with an aromatic transition state. Back in 3300, when we were determining which compounds were aromatic, an odd number of electron pairs, 3 pairs or 6 electrons, corresponds to an aromatic compound. For the 2+2 reaction down here, 2+2 meaning 2 electrons and 2 electrons. The transition state is anti-aromatic because it involves an even number of electron pairs, 2 pairs or 4 electrons, and that reaction cannot proceed thermally. Notice that in the 2+2 reaction, and let's draw that out, you would have the blue electrons coming down to form a bond and the red electrons coming up. And that would give you a 4-membered ring. This is the reaction that we're looking at. So the red alkene would have a HOMO, the highest occupied molecular orbital, and those electrons would be going into the LUMO of the blue alkene shown here. In this reaction, you can see that the HOMO of the red alkene and the LUMO of the blue alkene have one interaction that works, that has constructive interference, and the other is destructive interference. So this situation with destructive interference is not allowed. However, 2+2 cycloaddition is photochemically allowed. So that reaction that we just went through can occur with UV light. It cannot occur with heat. Alternatively, the Diels-Alder reaction cannot occur with light. It's actually considered to be photochemically forbidden. Why is this? Let's again go back and look at our HOMOs and our LUMOs, or our molecular orbitals. For ethene, remember our HOMO, the highest occupied molecular orbital, was here, and our LUMO was here. What happens in a thermal reaction is that we have the HOMO line up with the LUMO of another ethene, but in a photochemical reaction, one electron is excited by light. And that's the light here. HV is the abbreviation for light. So light is hitting ethene and exciting one electron up. So our HOMO now is this one here. Well, this HOMO, if you recall, looks a lot like the LUMO of an ethene. And now we have a HOMO-LUMO interaction where we have constructive interference. We have constructive interference on the right as well as the left. So this reaction can proceed. What you want to remember going forward as we're looking at reactions that are photochemically allowed and reactions that are thermally allowed, photochemically allowed reactions involve even numbers of electron pairs, 1, 2 pairs. Thermally allowed reactions involve odd numbers of electron pairs, or 3 pairs. So if you were to have a reaction where you had 4 plus 4, 1, 2, 3, 4 electrons plus 1, 2, 3, 4 electrons, this has 1, 2, 3, 4, and so this reaction would be photochemically allowed and thermally forbidden. So this reaction would proceed with light, but not with heat. That wraps up our discussion of photochemical versus thermocycloaddition reactions. Don't forget to do clicker question 4, and then move on to the next video.